66 million years ago, dinosaurs vanished almost overnight. Forests collapsed, food chains broke apart, and extinction reigned supreme. And in the warmer world left behind, a new predator slithered to the top. What could be the largest snake the world has ever seen? A snake longer than a bus and as heavy as a small car. It had a constricting pressure comparable to the crushing force inside an industrial car compactor. This was an animal that could snap a giant turtle shell like a cracker in its coils, and was capable of devouring 2-meter-long crocodiles. Titanoboa was a master of disguise, silently lurking deep in the depths of South American swamps to claim its next victim. Measuring in at 14 meters long, Titanoboa was not only the largest predator on the surface of the planet for at least 10 million years, but it also carries a fascinating, unique, and truly unbelievable scientific story. I'm James Stewart, and you're watching Astrum Earth. In this video, we'll unravel the mystery of Titanoboa, from its discovery in Colombian coal mines to how it lived, hunted, and was able to thrive in a way never before seen amongst reptiles. Finally, and perhaps most importantly, we'll ask the biggest question of them all. Where did this monstrosity go, and could it one day return? For most of the 20th century, there was a gap in the fossil record. The first few million years following the Cretaceous Paleogene event, one of the greatest mass extinction events in Earth's history, were poorly understood. The fossil record suggested recovery, a sort of bounce back period that would allow previously hunted species to thrive once again. What it didn't suggest was dominance, and certainly not gigantism, and definitely not from snakes. The saga of Titanoboa has more twists and turns than the coils of the snake itself, and it begins in an unlikely place, an open pit coal mine in Colombia. On the surface of it, Cerejón is pretty unremarkable. Lying in the lowland tropics north of the country, some 60 miles from the Caribbean coast, it's a forbidding, seemingly endless horizon of dusty nothingness, largely stripped of vegetation, a rare brown blot on the green map of Colombia. The area is crisscrossed with dirt roads leading to enormous coal pits, some up to 24 kilometers in circumference. In fact, this place is one of the world's largest coal operations, certainly the largest in South America, 700 kilometers squared, covering an area larger than the city of Chicago and employing some 10,000 workers. The multinational corporation that runs the mine, Carbones de la Cerejón Limited, extracted 19 million tons of coal in 2024 alone. But 60 million years ago, this area looked quite different. It was a sweltering, swampy jungle, hotter and wetter than modern rainforests, dense with towering trees and teeming with colossal animals. There is some irony in that all of that organic matter formed during the Paleocene epoch actually turned into the coal that's now being mined. Carlos Jaramillo, a paleontologist at the Smithsonian Tropical Research Institute, said that Cerejón is the best and probably the only window on a complete ancient tropical ecosystem anywhere in the world. So, if you knew roughly where to look, there's a very slim chance you might find something more valuable than coal hiding in these mines. The search for the monsters of the Paleocene epoch began in the 1990s, when Colombian geologist Henry Garcia found an unfamiliar fossil. He wasn't quite sure what he was looking at, so he placed the specimen in a glass display case in the coal company reception, where it was labelled petrified branch and forgotten about. Now, flash forward 9 years, and a geology student named Fabini Herrera was hunting around in roughly the same spot when he noticed something unusual about the stones beneath his feet. He reached down and picked up a piece of sandstone, turning it over in his hands. On the other side of the stone, there was an impression of a fossil leaf etched into it. He picked up another rock, and the same thing happened again, and then again, and again, and again. He had stumbled upon a set of beautifully preserved fossil leaves, which he brought to the attention of Carlos Jaramillo, who we mentioned before. Now, if like me you're thinking what's so special about fossilized leaves, well, yeah, fair enough. But they were about to reveal something far more intimidating, almost entirely by accident. Delighted with his leafy findings, Jaramillo immediately reached out to Scott Wing of the Smithsonian, an expert on Paleocene plants, and momentum began to gather. Now, what made this area particularly unique was that most fossils near the equator tend to end up buried beneath millions of tons of soil and vegetation and are largely inaccessible. But at Cerrejón, where humans have been whittling away at the ground for years in the quest for coal, well, there was now nothing in the way. Wing, fascinated by this discovery, wanted to see the mine for himself. When he arrived, however, it wasn't the fossilized leaves that caught his attention, but rather the long-forgotten petrified branch that had been gathering dust in the display case in the reception for nearly a decade. Wing's instincts kicked in here, and he started taking pictures through the glass with his camera. He then emailed the images of the branch over to paleontologist Jonathan Block of the University of Florida Museum of Natural History in Gainesville. Unbeknown to Wing at the time, the email he had just sent was about to profoundly sharpen our entire understanding of evolution. In Block's own words, he flipped out when his inbox pinged, and then the floodgates opened. What Block was looking at was not some petrified stick, but the jawbone of a land animal. There was a terrestrial vertebrate of an age never before seen in these parts. Block identified the jawbone as belonging to a group of extinct crocodiles called Dyrosaurs, one of the largest marine vertebrates to survive the Great Extinction event. And where one fossil was, there were usually many more. Fueled by a newfound sense of urgency, in 2004, Block and Wing planned a trip back to the Cerrejón mine. They called Garcia, the finder of the petrified branch turned extinct crocjaw, to ask where exactly to focus their search. The answer was an area in the north of the mine, particularly exposed and left baking in the extreme heat, an area called La Puente Cut, covering some 6,000 acres. The conditions were brutal. Temperatures reached well over 30 degrees Celsius with zero vegetation for shade. It was lashed by 40 km/h gusts of wind, methane fires and rain that each day would erase all of their hard work from the day before. Nevertheless, they persisted. Their patience was finally rewarded and the spoils were plenty. They grabbed everything they saw, you name it, ribs, vertebrae, bits of pelvis, shoulder blades, and even gigantic turtle shells, some of which were 1.5 meters in diameter. 3 new crocodilian species were discovered during this process, one of which was between 4.5 and 7 meters long. Another beast they found had a death bite capable of piercing a shell half a meter thick. This truly was shaping up to be the land of the giants. So they bagged up all these different bits and pieces they could find in plaster casts and sent them back to Gainesville in Florida for Block and his team to analyse. And they kept this up for 5 years. I feel like I spent the same amount of time on my own little version of this giant jigsaw puzzle, except mine has been a quest to get my personal data off the internet, which, okay, isn't quite as exotic as a Colombian rainforest, granted, but does feel just as arduous. When you make content and present stuff on TV, you expect there to be a few bits out there, and that's fine generally. But what's not fine are things like my email address, home address, and family information, all being readily available to be sold off to data broker sites. Forget Titanoboa, these lot are the real snakes out there, I'm telling you. So this year I've been using Delete Me, and honestly it's been a total game changer. When I first started using it at the start of the year, I had 6 data breaches, which put my data at significant risk. Luckily, thanks to Delete Me, I now have 0. Just last week I had a couple of spam emails that came through, and all I had to do was simply make a request via the online portal and it was sorted out really quickly. And it's very satisfying to shut down the spammers, I must admit. If that sounds vaguely relatable to you, then why not join Delete Me yourself? They're giving our viewers an awesome deal right now, 20% off with my link, joindeleteme.com/AstrumEarth, and use code AstrumEarth at checkout. Thanks to Delete Me for sponsoring this video. The link is in the description if you want your digital life a bit more private, as we head back to our search for the world's largest snake. It was now 2007, and Alex Hastings, a then grad student at the University of Florida, was going about his now daily task of unwrapping the vast array of packages that landed on his door from Colombia. In amongst these, he came across a single vertebra, strange looking and enormous. Based on its size alone, it was labelled as a croc, but Hastings knew instantly that something was different about this one. This was not a crocodile at all. So he showed it to his lab partner, Jason Bork, who agreed. "That's a snake," he said. But this was not like any snake the world had ever seen. Bork raided the university's fossil collection, pulling out the closest looking vertebra he could find, that of an anaconda. It wasn't a perfect match, although it looked quite similar. The only problem was the anaconda vertebra was 3 times smaller than the new fossil they had just received. How could a snake be this big? Surely it just wasn't possible. They needed more evidence. They sent word back to the team on the ground in Colombia that more specimens were needed, specifically of fossilized snakes. Eventually, the team collected 100 snake vertebrae from nearly 30 individual gigantic snakes. Now, the most amazing part about all this is that Jonathan Block himself had also been sifting through specimens over the last couple of years, and he had also received giant vertebrae just like this one, but even someone with his expertise had totally dismissed them. He said, "It's like someone handed me a mouse skull the size of a rhinoceros and told me, that's a mouse. It's just not possible," except now he realised that it was. The only problem was they had no idea what kind of snake they were dealing with. Realising what was at stake, Block called Jason Head, then at the University of Toronto, the world's leading snake expert at the time. After exchanging a few images, Jason Head booked his ticket to Florida that night. The pair got to work immediately, honing in on the vertebrae from 2 different individual snakes, and that's when Head spotted it. The creature had a very clear T-shaped spine, with bones unique to only one type of animal, boyd snakes, the lineage that includes boa constrictors and anacondas. Now, both of these snakes are common in these parts. Boas can reach up to 4.2 meters in length, and anacondas can exceed 6 meters. So that was nothing crazy, but something was wrong. The bones they were looking at seemed to suggest this unknown creature was more closely related to boas, but where it had been found in Cerrejón was more akin to the habitat of a modern South American anaconda, a river and swamp dwelling snake comfortable in the water. And there was another problem too. You see, they still could not grasp the true size of just what they were dealing with. Snakes are tricky. They rarely end up being fossilized as their bones are very delicate and break, which means it's very hard to find an intact and complete skeleton. But the team had one final trick up their sleeve: mathematics. Up in Indiana, whilst the team in Florida had been analysing samples, another paleontologist, David Polly, had spent the last 2 years building what was essentially a mathematical model of how a snake's spinal column looks, based of course on living species. Each bone corresponds to a specific region on the snake's back, but no one had really pieced that together before. So Polly and Head put their heads together, and using this mathematical modelling, plotted each joint, ridge and individual vertebrae as a set of coordinates on a graph, and they were finally able to get an accurate picture of the snake's length. What they unravelled was a 13 to 15 metre behemoth, weighing in with a mean of 1,135 kilograms, as much as some fully grown rhinos and the length of a school bus. Titanoboa cerrejonensis, or Titanic boa constrictor, was formally named in 2009 in a Nature article, and it flipped evolutionary science on its head. For context, the largest anaconda ever accurately measured was a mere 8.5 meters. For some, this was the stuff of nightmares, but for the scientists who had dedicated decades to this search, it was the stuff of dreams. They had found the largest snake ever to have been discovered. While Titanoboa's size was enough to make headlines around the world, what scientists still didn't know was how it lived. It was incomprehensible. What type of world could produce such a monster? And crucially, what did it do to survive? There was still one part of this monstrous jigsaw puzzle missing: a skull. As incredible as all those discoveries we've just talked about were, the modelling only really revealed the size of the snake, which is impressive enough. But to get a full grasp on this almost mythical creature and to further advance their research, they needed its head. So they once again headed back to the coal mine, which by now to them surely must have felt more like a gold mine. When they touched back down in Colombia in 2011, expectations were very low. They'd already hit the mother lode. Surely, lightning couldn't strike twice. Finding a snake vertebrae was hard enough, but finding a snake's skull, well, that was a different world. Unlike our skulls, snake skulls aren't fused together. Instead, they're connected with tissue, tendons, ligaments, and muscles. What that means essentially is that when the great beast dies, that connective tissue would simply decompose, and all those tiny little bones would just disperse. This wasn't even a needle in a haystack kind of situation. They were looking for fragments at best. And miraculously, that is exactly what they found. Call it divine intervention, luck, or just knowing what they were looking for this time. Block and Head were able to find 3 individual skull bones. They spent weeks meticulously comparing the contours of those individual bones against modern boa, anaconda, and python skulls. This was not glamorous work. These weren't the big headlines that I'm now talking to you about in this video. This was painstaking, laborious hours of looking under microscopes for the tiniest of differences. And not for the first time, that patience was rewarded. The fragments suggested Titanoboa's whole head could have been nearly a meter in length. It had a special hinge bone too, a quadrate, that connected its lower jaw to its skull. Now that allowed the back of the lower jaw to extend behind its brain. This thing opened its mouth big and wide, and it was full of closely packed teeth too. Now, interestingly, those closely compacted teeth are a trait found in modern snakes today that specialise in eating fish, but no known boa alive today actively specialises in hunting fish. All of that evidence points to a semi-aquatic lifestyle for Titanoboa, with behaviour more like today's water-dwelling anaconda than a boa constrictor, but they still couldn't say for sure if it was more boa than anaconda. With a skull that showed a shallow quadrate angle and its preference for a swampy habitat filled with giant fish nearby, a new picture emerged. Titanoboa may have been the only boid of its kind, a supersized fish-hunting serpent, unlike anything else we've ever seen. This wasn't a fast, dynamic, land-dwelling predator. Moving a ton of muscle wasn't easy. Instead, it likely lurked in swamps, taking advantage of buoyancy and using water to regulate its temperature. This was a predator that waited for prey to come to it, lying camouflaged against the dark tannin-stained waters. Titanoboa's size also raised bigger questions that stretch far beyond its anatomy. Why was Titanoboa so much larger than any snake alive? Something had to allow for this gigantism. And as it turns out, the answer to that question also has implications for the entire planet, and that includes us. Snakes are ectotherms. They depend entirely on the warmth of their surroundings to regulate their body temperature, and this dictates pretty much everything else about them: their metabolism, what they eat, where they live, and of course, their size. As such, we know that the boid snake family tends to live in tropical environments, especially in South America and Southeast Asia. Here, the hot, humid environments allow these cold-blooded creatures to grow and to thrive. The warmer the environment, the more energy they can absorb, the faster their metabolism, the more they eat, and thus the bigger they grow. When the team spent all of those hours analysing fossils and building mathematical models, they weren't just looking at a fossil record, they were looking at a climate record. Titanoboa was not an accident. It was the outcome of an extreme world. For a snake to grow this big, those hot, humid temperatures would need to be supersized almost as much as the snake itself. The team estimated that to grow to this size, Titanoboa must have lived in an extremely warm climate, a far warmer ambient average than we see today, with year-round temperatures between 30 and 34 degrees Celsius with no let-up. The Paleocene tropics were a scorching, sweaty sauna. The same concept applies to other reptiles too, explaining the turtle shells the size of snooker tables and humongous crocs, the very things Titanoboa would eat for breakfast. Remember those fossilized leaves we talked about earlier on? Well, they back this theory up too. Studies of carbon isotopes and leaf pores from those samples indicated atmospheric carbon dioxide levels were about 50% higher than they are today, likely driving those high land temperatures. So what if I told you that a 60 million year old snake the size of a bus lurking in a relentless swampy jungle could actually impact us here on Earth today? You see, these findings help scientists understand how ecosystems respond to warming. Rising greenhouse gases are currently heating the planet, and extreme temperatures can cause plant and animal die-offs. We've seen that already, sadly, in some parts of the world. Plants, for example, may eventually reach a point where they can no longer photosynthesize effectively and they begin to die. Yet during Titanoboa's time, the region supported a lush, highly productive forest. So how can both things be true? What this suggests is that there are some ecosystems that can thrive in very warm conditions if they have enough time to adapt. Because the plants and ecosystems in this region have already coped with those really high levels of CO2, it might mean that those plants and animals already have the genetic ability to cope with global warming. And that raises a big question. Could, therefore, Titanoboa return as our planet continues to warm? The news is either terrifying or exciting depending on your view, because Dr. Jaramillo, the guy that started this whole thing off, says there's a chance. Before I get your hopes up too much, the key difference here is timescale. Ancient warming happened over millions of years, and this gave the species time to evolve. Today's climate change is occurring over just centuries, and in some cases even quicker than that, which may not allow enough time for many species to adjust in the same way. In other words, if Titanoboa is coming back, we certainly wouldn't be around to worry about it. But what if we didn't have to wait at all? What if it was already out there and we just haven't seen it yet? I know that sounds pretty wild, but rather like Megalodon, the internet is alive with those convinced a bus-sized snake is still lying in wait somewhere out there right now. After all, large swathes of the Amazon are still largely unexplored, so it could be hiding, right? Wrong. Titanoboa, as we've discussed, lived in a very specific climate that no longer exists, even at our current rate of global warming. Moreover, not only have there been no credible sightings or remains of any 12-meter snakes found, we sort of don't need there to be. Titanoboa was the apex predator during its time. If it was still alive today, hidden or not, the food chain would look very different, and so would pretty much every animal it once ate. All that remains of this once great monster now is found in fossils, not forests. The story of Titanoboa strikes a special balance of mystery and science. It was an animal almost beyond comprehension, a snake that outsizes anything we know, and for years, its very existence was unknown to us, buried in rock. Through scientific curiosity and the sheer perseverance and collaboration of so many individuals over so many years, they were able to come together to make something great, to decode its life piece by piece. What emerged is not a myth or a movie monster, but something far more intriguing. A real creature that tells us about the extremes of nature. And there might still be more to come. In the last 2 years, scientists in India have uncovered another snake vertebrae in the same league as Titanoboa. Dubbed Vasuki indicus, the vertebrae found are 11 centimeters in diameter, which is not far off Titanoboa. We'll watch to see what new clues are found in the months to come, and who knows, maybe Titanoboa's title is under threat. Until then, this great creature continues to spark the sense of awe that comes with realizing that such a world truly existed. If you got this far in the video, thank you. Please let me know by dropping a snake emoji in the comments as a tribute to this wondrous freak of nature.